discussion. We talk generally about hardware and why we are so interested in hardware and why we focus everything we do in hardware. So Nigeria is facing serious power challenges, right? We now discover that, okay, we have enough solar resource, that is, there's enough sun because of the position we are in the earth. There's enough sun to solve all the energy problems we have. Nigeria is the largest economy in Africa, one of the largest population in Africa, but we don't manufacture basically anything we use. And what this does is that it gives the opportunity to all these guys that manufacture. If your laptop cannot function, you will not do nothing. If you design all the software you want to design in this hall, if these ACs are not here, these lights are not here, you cannot do anything. If this projector is not working, you cannot do anything. So these people have understood these things and they've developed themselves. So, sorry, I did not introduce myself. This is how I call myself. I'm a Delta boy by parents. I'm a Benue boy by growing up, grew up in Benue State. Then I'm an Enugu boy. I schooled here in Enugu, schooled in UNN. Then gracefully, I met some of my fellow students in UNN. We started everything that we are doing today, Green Age Technologies, Hardware Garage, so many other things that we are doing today in Enugu. We moved from Nsukka after school to Enugu, where we set up, had some investors that gave us money for us to set up properly to get to the manufacturing level that we are, and then we are now focusing in Enugu. So Green Age Technology basically manufactures inverter solar equipment, generally here in Enugu. Our factories at number 10 Enugu on the Expressway. I think after here, some people I would really like that you come to the factory and see some of these manufacturing processes going on. We are the only company in Nigeria that has a complete SMD pick and place line. So we manufacture our inverters. Everything is here, we manufacture everything here from start to finish here in Nigeria. So sometimes there are some things we manufacture here in Nigeria. We manufacture and we send to Lagos. Then they'll package it how they want to sell it. So this is going to be like an electronic design training course. So it's one of the sections of the hardware garage where we focus on training people. So it's going to be about designing and fabricating of professional electronic equipment. Why we focus on making everything professional is because gone are the days where, because they say something is locally made, it should be substandard. Because something is locally made, it should not be able to behave as whatever that is made in China or India. So you have to learn to do these things professionally. So whenever I teach people about hardware, I try to talk to them about some basic rules, so that these rules will help guide you, so that you don't become frustrated along the way. First thing is that it's usually a training research-backed form of training. What I mean by this is that not everything you are not going to be taught everything. There are some things you are going to just give in the direction, and then based on your research that you are going to do personally, then you are going to have to come up with the way going forward. So you are not going to be spoon-fed everything. Then the next thing is that each course will be backed by various projects. So whatever you are learning is going to be backed by various projects. So even somebody that is going to be learning about inverter, the first project you are going to do is not going to be an inverter, because an inverter is made up of various sections, right? And each section can function on its own. So an inverter, there's a part of the inverter that has to do with changeover. So that when your inverter is connected in the house and then there is NEPA, you will not know, Abi. So automatically change you over from inverter to NEPA and so on and so forth. So that is just a section of the inverter, right? Then the next thing is going to be examination. So tests and examination, because we usually give tests from time to time, so to know how far your training is going. And the examinations basically are usually projects. You are going to be given sample projects to design on your own and to know how far you'll be able to go with them. Then we give certificates based on that. So there's a basic rule like this. I say hardware production in Nigeria is not the same as hardware production in China. One of the basic things you are going to understand is that you must learn the limitations of the environment you exist. There are some limitations operating in Nigeria is a frustrating place. There are some things you are going to look for. And you are going to now wonder, so this is not in Nigeria, as big as we are. And the definition of big for nothing. As big as we are, there are some simple things that could create thousands of jobs, and nobody's doing it. And you know why nobody's doing it? Because there's no market for it. Because even if you go and do it, who will buy it? So you see both things. So there are going to be some frustrating things you are going to see on the way. We're going to talk about basic electronic components. We're going to talk of SMPS and power electronics. We're going to talk about PCBs, printed circuit board, and we're going to talk about professional projects. I'm going to apologize to you. The part that talks about the solar training is missing from this slide, so I'll not put it up as the discussion goes along. You are going to understand what you want to do in detail. So there are some of you that I said that want to do sound system. You might want to do the sound system that will power this whole hall, that will sound well in this whole hall, right? But you might not be able to start with that. You might be able to start with something little and then you build your way up. All right, so the next thing is going to be a paper design. Usually after your feasibility studies, you should be able to come up with a paper design. So somebody that wants to do an automatic changeover after his paper design. For you to come up with the paper design, there are other things that you're supposed to do. You're supposed to actually understand how to come up with the paper design, right? So for it, at the end of the paper design, you're supposed to know, okay, I need 10 resistors, 20 capacitors, 50 diodes. You're supposed to know all these things, so you now get a BOM and know what you are supposed to work by. So when you have BOM, it will help you to walk back to you to get something. So the next thing is going to be the actual manufacturing. So this is where most people face challenges. So now you have the design, you know what you want to do. How do you bring it to life? So that is where you are going to now look at. We're going to try to talk more about that. We want to go about the manufacturing process. Then we're going to talk about after-sales services. So the after-sales service is very important when you are starting anything you are doing. There are 3 basic components in any electronic design that you do, which is active components, which involve transistors, diodes, generators, and other current and voltage sources. Then there are passive components. These passive components don't create any form of charge. They just help you control. They are just like a means. For example, something like resistor. A resistor in a circuit, what it basically does is that it limits the flow of current. Resistance, the smaller the current that will flow through a particular circuit, right? So the same thing with an inductor. An inductor works in another way. Let me not explain it too much so you not get confused. The capacitor, what the capacitor does basically is stores charge. It's like a mini battery, right, in a circuit. Because when you are designing a circuit, there are some points where you want to store charge at some point and then I don't need loss. So capacitor usually helps with things, maybe you are trying to do things with timing. You want something to wait for 2 seconds, something to wait for 3 seconds. You can use your capacitor, charge, discharge, and so on and so forth. So it's very, very important. So you're going to see most of these things once you get to the various workshop sections. The same thing with electromechanical, mechanical switches, things like relay. You see relay, you see a relay. Whenever the thing, in your stabilizer, you hear that thing that is do king, 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 when light is working, right? So those are relays working. How your stabilizer basically works is that you check the voltage. There's a transformer that has multiple tappings, right? Each tapping has different voltage output. So based on what NEPA gives in, something will read and say, voltage is 200, or it will use relay to select a particular tapping that will now make the output be what? 220, and so on. So that just helps you balance. So all these components. So we see electronic design like you're trying to build a city. In that city, you have different points, and each of these points are going to be, each of these things that are going to happen is going to make use of at least one of these components, which is going to make use of an active, a passive, or an electromechanical component. So, okay, this is about SMPS and power supply. So why we put this is because it's one of the major parts of every electronic design that you are going to do. The SMPS and the power supply, what we usually call power pack, is going to be one of the most essential part of everything you are going to do, because everything you do must have something that will feed, that will supply power to it, right? You have your laptop, you must have a power pack. You have your phone, you must have a power pack. Even in your TV, the fact that you're just seeing one cord, there's a power pack inside. If you open this AC, there's a power pack inside. If you open basically any electronic device, and what the power pack does most times is because most of these things are DC components. You are going to learn more about it when I'm talking about solar. Most of these things are DC components. But what is supplied is what? AC. And because AC is supplied, you have to convert AC to what? DC. And at various voltages. So that is why this power pack is very, very important. So basically, there are different types of control. The PWM controller. So this is like the basic thing that helps you control what is going to control the voltage. So it's like the brain is going to say, okay, I'm going to send out this amount of pulse, and it's going to work on this, it's going to work on this, but let me just keep that. You are going to learn SMPS and then microcontroller-based inverters. There are some people that also manufacture inverter. They are trying their very good best. But they have one basic challenge, because they're not using printed circuit boards and it's not very professional. If they sell their inverter to somebody, that person cannot take it to a repair technician. For example, say to somebody in Oakland, he cannot take it to a repair technician in Oakland. He will travel to Oakland. When you travel to Oakland twice, the next time someone in Oakland say, I want to buy an inverter, you will say, okay, I know they do inverter. This is what I mean by printed circuit board, right? So this is what they call it motherboard. Since motherboard, they call it, yeah. So once you say motherboard, right? So you have to design this. So what this helps you is that it helps your system to be compact, helps whatever design you are doing, it will look professional. If somebody carries it, most times we write made in Nigeria on it, because most times somebody carries it, they will not believe. If there's no made in Nigeria, the person will say it's a lie. That this thing that he made, that he went to import something and then change something and then couple something, that you're not the one that designed it. So for that reason, we always write made in Nigeria in all our products so that you'll be able to understand, so that we'll be proud of actually what what we did. So the printed circuit board, so like I said earlier, Pro Tools or Eagle CAD will help you design it. So most times we now have to go to the stress of having to train people 6 months, 1 year, so that they can be able to understand that thing to the point where they can work for it, becoming a challenge. We are building our permanent factory, building our permanent site. We are going to need maybe 200, 300 workers. How are we going to get 300 people in Nigeria that understand how to do most of these things? It's going to be a challenge. So most times I say we are not training back, and why we focus on your training, and what is going to be beneficial to you mostly is because the training is usually hands-on. As you are learning whatever you are doing, like you are going to do here, you are going to be feeling it. It's going to be something you are learning as you are doing it. But if you are not passionate about hardware, leave it, because the frustration when you start is going to be challenging. And because you are like, we hardware designers, we see ourselves like gods. What I mean is that you are designing something that is coming to life, something that once you are done, it does something that produces a physical response, something that produces, if you build an inverter and power it in this hall, it gives a physical response. You see lights coming on, you see the system start moving. Somebody that is doing electric keke, when it does it, the keke will move. It's like you are doing something. So until you get to that point where that thing has come to life, you'll be behaving like a madman. And everything will not interest you again, because you feel like it just remains small. If I can just correct this thing will work. And you correct that thing for 6 months and it does not work. So that's the thing. So you have to be passionate about it. So, like I said, some unspoken rules include, at every point in your design process, you must first remember that you are what? You are in Nigeria. You are a Nigerian in what? Nigeria. There are some people that will start thinking that Silicon Valley in USA, or they are in Shenzhen in China. They want to do magic. You want to start from Z. You don't want to know A. So you have to humble yourself and know that. Second, I say passion. If you are not passionate about the product, don't waste your time. The next thing is don't listen. People will advise you on what you should be doing and what you should not be doing. Now only you know what you carry for your head, though. As you are building, someone will come and say you are doing power bank, you are wasting your life. Go and do inverter. There's money in inverter, leave power bank. Now only you know. If you leave that power bank, go meet 20 people. People when they inverter, another person they advise them, oh, you are doing inverter. You are wasting your time in doing this inverter. Go and be doing solar installation. Somebody do solar installation, somebody else is advising him. If you fall from roof, break your leg. Leave solar installation. Oh. Go and do power bank. Somebody is telling somebody to leave power bank and do solar installation. People will always advise you what to do and what not to do. Somebody asked me personally, because then we manufacture the inverter, people were refusing to buy. So what to do is that we will now use the inverter to do solar installation for people, so that installers can trust the product. Someone asked me, why don't you just go and buy the one in the market and put and not suffer from any of these challenges? Because I was like, why don't I just go and buy what is there? And still tell people I'm doing it too, but not do it. And just go and buy whatever is in the market and put for people. Possibly change label and do anything that I want to do. But sometimes, because of the team I have, they were like, Omo, we came to cause change, right? We came to so that we tell people that this is made in Nigeria. We don't have to do formats. We don't have to hide left and right and protect the image of that thing. So we'll be sure that is what we are doing. So we kept on. Before, coincidentally, we were not able to get our first investment, which was around $67,000, right? That was our first investment that we got. You understand? So get a team is very, very important. Team is very, very important, at least to help you reduce the mental stress. So what I'm just trying to say is, don't do it alone. Look for people, join together, prioritize based on your skills. And then, after prioritizing, remodel your process to start with the easiest way to achieve the available resources. In hardware, I advise people, don't think big. You know, have you read this book? They say Think Big by Ben Cassie. Don't think big in hardware. If you think big, big will humble you. Because if you think big, you will never be contented with what you have done. So what you do is that don't think big too much. Just think according to what you have. If possible, think smaller. There's nothing important in hardware design as encouragement. If you are able to do one thing that works, there is no encouragement that is more than that you have done one that has worked. If you are doing inverter and your inverter works for only 1 minute, you are better than somebody that is doing plane that has never worked. So I call it solar installation 101, basic of what? Solar installation. It's made up of the solar panels, the solar charge controller, the solar panels generator. So I'm going to, at this point, I'll explain it by pursue generator, right? So in your generator, the solar panel is the fuel. It is the actual source of energy. The fuel is the actual source of energy, right? Then the charge controller will be like, what's it called? Carburetor. Of now you know the carburetor, right? So it controls the amount of fuel that goes to the coil, right? But for this charge controller controls the amount of charge that goes to the main coil itself in your generator, right? Then also your battery too, right? So in battery, your fuel tank is what? The battery. Fuel tank. What does the fuel tank do in your generator? It just stores the fuel. It doesn't produce fuel. It doesn't do anything. That is exactly what a battery does. It just stores whatever you give it. So if you give him enough charge, it will store it for you, and when you need it, it will give you back. It doesn't do any other thing. Then the next thing is now the inverter itself. So the inverter is like the coil in a generator, right? So it determines the maximum load that your solar system can carry. So if your coil is good in your generator, if it's a 5 kVA coil or a 10 kVA coil, then it can carry 5 kVA load or what? 10 kVA load, right? So that is what the inverter does. It's just the coil that it does the main loading. It does the conversion. Your battery is what? DC, right? Your fuel is just fuel. It is not electricity. It is that coil and how the generator will do its thing that will now make that fuel to become what? Electricity for it to use. And that is what this inverter does. So it helps you convert what is in the battery. You can't use what's in the battery in power this place. It goes to the AC circuit, which is your house and everything. Then I put generator there because some people also have what they call auxiliary supply. So they can have generator also connected to their inverter, so that at any point their battery is low, automatically the gen can take over. Also AC input, you also connect AC or NEPA to your inverter, so that if there is NEPA, you can, you know, we are presented with a unique challenge in Nigeria. So that is why some of these things are added to make your solar system complete. So let's go to the next thing. So facts and fallacies about solar energy, right? So I started with solar generator. So I said solar is not a generator, but you can provide any power a generator can provide. And I can compare, like I explained earlier, right? I tried to compare both of them, right? So the next thing I said, solar is not what? Expensive, but it's what? Capital intensive. I'll explain what I mean. What I mean is that when you install a solar system, you might think it's expensive because you paid 1,500,000, 300,000 for it, right? But if you compare it to your neighbor that is running generator, in 1 year or 1 year plus, you'll be able to recoup all the money you spend. He's still spending, but you have stopped what? Spending. That is where you now start seeing that. The only thing you just did is that you spend money you should have spent for 1 year. You spent it once. The next thing, solar doesn't work. So I said, the performance of solar installation depends on the installer and the equipment. What you buy is what you get. There is no magic. There's what some solar installers do that I will not advise any of you here to do. They do what they call make the client enter. Client that needs 10 batteries and 12 panels. He will say, I don't have money for 10 batteries and 12 panels. You tell him, do you have money for 2? The person will bring money for 2. He has what? Entered. And once he enters, there's now frustration because people will be arguing every time. So I talked about solar resource. So first of all, a lot of things people talk about solar energy in Nigeria. They say, what do they call it? Like differences that you can apply. But in general, what this explains is that based on the amount of land mass we have in Nigeria, we have more than enough space or more than enough solar energy to solve all our power problems from using only solar. Why to tell people this is because some clients are going to tell you, but I want power AC. Can it power AC? There are buildings where we've powered small buildings that have maybe 10, 15 ACs, and they are still running full time. Is there anybody here that can help us with, anybody that can tell us the main components of a solar system or a solar installation? Anybody here can help us?
Okay, the main components of a solar system starts from the solar panel. then to the charge controller, then to the battery, then to the inverter, then now have the load it carries.
All right. He did not mention the source. He just went straight to the panel. Where did the panel get its supply?
So, as we're saying, so far, you see the challenge, have you? So, basic calculation and formulas, don't assume. You would think somebody doesn't have money to pay you. You now go and assume and tell them something smaller, and they'll tell you, come and start. It will change. You can't go back again. And the first thing you can do is, at that point you are talking to that customer, you should be able to answer him first, before you even leave there. So if you don't know how to do some of these basic things, you can't be able to, do something. So I say basic formula. So I'm going to speak on basic things, I mean. So we'll try to understand solar energy itself, I mean. The first thing is forms of energy and the laws, right? I talked something about potential energy, heat energy, chemical energy, electrical energy. I don't want to explain those further. I think we can read up on that later. So I talked about law of quantity and quality. So the next thing you need to understand is power, energy and power. Is there anybody by virtue of what you have done that can give me a basic difference between energy and power?
Energy can be defined as the ability to do work, or is also, and measured in joules, while power is the rate that work is done, which is IV in mathematics.
Bro, you can't confuse us with formula on top. So let's not, so that we'll not waste too much time. Thank you. So he got it. Why I wanted people to explain that is that, like they've explained, energy is the ability to do work, right? But power is the rate at which you do that work. Power is measured in watts. Why I'm putting some of this here so that you understand this unit, because these are the terminologies you use when you are talking about solar. You can't do anything in solar energy without understanding the terminologies, right? So that is power. Why energy is now watt hour? The amount of work you have done in what? 1 hour, right? Or kilowatt hour, right? So some of these things just be understanding so that once we get to we will not need to come back to this place, right? So even if you don't understand it, just write it down somewhere. So the next thing I'm going to talk about is what voltage and current. It's also very important. Can anybody tell me the difference between an alternating current and a direct current?
Okay. Good afternoon, everyone. I think the main difference between an alternating current and a direct current is that an alternating current, it changes direction.
Okay. Thank you very much. So like an alternating current it changes direction with time. It depends, there can be different forms. It can be sinusoidal, it can be square, it can be different, but it changes direction with time. So typical example of what alternating current is like your NEPA light, right? NEPA is alternating current. What comes from your gel is alternating current. Anything that comes from a form of coil. So the next is going to be battery capacity and storage. We are trying to understand the symbols here, right? So the capacity of the battery is the quantity of electricity. Battery here, what's like the normal units they mention with battery? They say amp hour, right? The one that's very popular now, power bank, mAh. And I will just give one quick tip here. When you are buying a power bank, it's not the AH that always matters. Because you go and buy power and I tell you 20,000 AH. What is the actual power? So there's 20,000 AH, but the batteries are cascaded to a particular voltage. The actual power that thing can give you is the product of what? The ampere and what? The voltage. This is where we come to energy. So whenever we're talking about what is stored in your battery, you talk about the actual energy, right? And we say energy is what? The rate at which power is what? Expended. So it is the product of what? Product of power and what? Time, right? So that is where we get, if you look at my slide here, it says energy is what? Watt hour, WH. So most times at the end of the day, you hear they say the storage capacity of the battery is 10 kilowatt hour, 15 kilowatt hour. They're trying to tell you the amount of energy that is what? Stored. And to simply get it, because these things are going to be important once we go to the next place. To simply get it, you multiply what? The voltage is power times time, right? And we rightly explained here that power is what? Voltage times what? Current. If you don't understand it, don't write it down. Don't crack your head because you can just look from what you wrote down and then do your normal mathematics. This is only theoretical. Remember the law of quality, right? So at the end of the day, when you are calculating, you understand that some things will be lost on the way. Let's go to the next slide quickly so that people can go and see for themselves. So we talk of solar panel, right? So when you're trying to come up with everything, the first thing you need to understand is solar panel, right? There are two types, monocrystalline and polycrystalline. Very important that you know this. The basic difference is going to be that monocrystallines are more efficient. In fact, they are gradually phasing out polycrystalline solar panels, so most people don't actually use it again. So for the purpose of going ahead of myself, when you are doing your installation, is try to stick to monocrystalline. Except the client said I already have panels. Then you now work with whatever the person has. But you need to understand. So when you go to the solar section, they'll tell you more about that. So capacities, you can switch from 10 watts peak to 700 watts peak. But why I want to say this is because it's very important you understand what is available in the market. So that you not go to the market and start sounding like a layman and say I want to buy 225 watt panel. Cascading simply means to connect more than one panel to either increase the voltage or increase the current. Once you get 10 panels, sure you must connect it together. Right? Normally now, you must join them for them to work now. So the process of joining them for it to work is what? Cascading. So you have to actually understand how to do what? Cascading. So you don't connect something and then you start seeing smoke. And that's how you connect it. You now be seeing smoke. You now be wondering, where is smoke coming from? It has burnt like that. So you have to understand how to connect it so that it will become what? And then the next thing is, I've talked about cascading. Connecting, you have to calculate wire sizing and so on, so that you can now connect it to the charge controller. Most times, your solar panel goes straight to where? Your charge controller. The one we call MPPT, it's fully called Maximum Power Point Tracking Charge Controller. You know what is PWM? I'm going to give you a basic layman difference. One is intelligent. The other one is what? Is dull. The MPPT is always trying to locate the maximum power that the solar panel can generate. But the PWM, nothing concerned now. Anything he sees at any point, it is what he gives to the what? To the battery. So I think by default now, you should know if a client is asking you whether you want to use PWM or MPPT, you should know that you should stick to MPPT. Except the client doesn't, because the cost, there's a cost difference. But most times, it doesn't really matter because the charge controller is one of the cheapest part of the whole solar installation. So even if you reduce cost from charge controller, you are being penny wise, pound foolish. You are just reducing the efficiency of your installation without any actual effect in the overall project cost. So next we talk about batteries. The same thing to batteries. There are two major categories that exist now, right? So there's the lead acid batteries, and then there's what? The lithium batteries. The lithium battery has a lot of advantages in the fact that it takes small space. Lithium battery is typically the kind of battery in your phone, right? While lead acid battery, the kind of battery you see in car. So now, then these other lead acid batteries are the typical batteries you see around, even in other solar systems. You are going to see what a lead acid battery looks like when you get to the solar stand. So, but the only challenge here is that the lithium battery is much more expensive than the lead acid battery. But it lasts much longer. A lead acid battery can stay 3 years to be working. So by the time you consider the cost and the time, it now boils down to the client, the amount of money he has now. There's an inverter. You know, you can think of any gen. You can think of any generator size, 3.5 kVA, 5 kVA, 2.1, you understand? So any size you think of for a generator, there is a complementing size for what? An inverter. So this helps when you go to the market, you can easily pick one thing, and say, okay, what I need is a 5 kVA. You get to where you learn how to calculate to know what you need. So the next part is what? Cascading. You have to learn to, not all inverters can be connected together, right? So the connection is going to be what? Specific. So the next thing is now the general pre-installation process. So we have started having PV size. Now you want to tell the person, this is the amount of solar panels that you want, that you need. Because you need to be able to tell the person. So the most important thing is that you have to understand that your client is the most important person. So first start with the client. The client will tell you his total needs. So what you also need to ask the person is, how long should these bulbs be on? Nigerians like the word 24 hours power, right? But we can't afford, an average Nigerian cannot afford to pay for 24 hours. So you, to save yourself the stress and make yourself feel like a bad person for telling somebody big money, you ask the person, how long do you want these things to be on? Let's say each bulb is staying on for 6 hours, right? You get the quantity, you get the wattage, and then you get the time, right? We say times 6 hours, right? So now we want to get, for the bulb, we'll get the total energy needed to power this bulb. And I say energy is what? Power multiplied by what? Time, like we explained earlier. So we have 10 bulbs. 10 times 5 is what? So we have total of 50 watts, right? Multiplied by 6 hours, right? We now have what? 300 watts. 300 watts hour. So we now have the energy for bulb. So what you are going to do when you are trying to estimate for your clients is that you are going to calculate the energy needed for each and every item. Very important. We have calculated bulbs, right? The next thing is fan. Let's say fan. I'm using the basic things. How many fans? 3 pieces, right? Fan, typically how many watts? 60, 70, let's use 60. Always confirm. If you don't confirm before you take a general value, but make sure the general value you are taking is out of experience. Now, even if you don't know, tell the customer that what you are providing will power 3 pieces of 60 watt fan. So when at the end of the day, you now discover that it is not 60 watts, you say, see, what I have been telling you, now 60 watt fan, but this your fan is more than 60 watts. How can we change it to something that is 60 watts? The moment you have already told him this, he can't hold you responsible for anything. You've tried your best, right? So somebody should quickly walk me through. How many, let's say the fan and the light will stay on the same time. So let's say this is also 6 hours, right? So how do we get our energy for fan? Somebody should just say it now, so we can. So multiply the three pieces by what? 60 watts, right? Times what? 6 hours, right? So what do we get? 1080. Okay. 1080 watt hour. Can I install? So battery sizing. The first thing you ask is backup time. For the panel, we ask for the whole time, right? That you need that thing to be on using solar, right? For the battery, ask for backup time. For battery, you don't need the whole time. Let's do a quick math. Charge controllers are rated by, say, amps and volts. So they'll say this charge controller, because we have 2 batteries, the maximum voltage our system can work with is what? 12 plus 12. That's the maximum voltage. 2 batteries. Connect the maximum we can get is what? 24 volts. To get the maximum voltage, add up all the, if you have 2 batteries, you multiply the voltage, which we said it's 12 volts, right? Multiply the 12 by what? The number of what? Batteries, right? So we say 12 times 2, so maximum is 24 volts. So if we are choosing a charge controller, we can say 24 volts by 30 amps. We are going to do the math, I will know if it's going. So 24 multiplied by 30 is what? 720. Is it less than or more than our total solar panel? It's less, right? So we'll go to the next popular rating, which is 60 amps. That's in total, right? So for the inverter selection, you now have to get the total peak load. Now, it's not about what the person wants to power. It's the total load that by any chance will come on that inverter. That's what you are checking. So although when you are connecting, you do what they call load separation. You connect some things that are not going to power, like AC and blah, blah, blah. You not connect them to the inverter themselves. You separate them. If you can't do that, you have to find an electrician that can do it for you. But peradventure, there are some loads that you want to connect, because in the whole house, you might not necessarily connect only the 6 bulbs. There might be 4 TVs in the house, and you cannot go and separate 2 TVs from another. But what you are telling the person is that the total you are going to use at every point in time is what? 2. So when you are calculating the size of the inverter, you take everything that is connected. So there might be 4 TVs connected, and it might be a 6-bedroom flat. There might be 6 fans, and there might be 50 bulbs, which is not what we use to calculate how much energy you need, but this is what is going to be connected. But when they are using it, they are not going to know how to use what they have estimated, right? So let's say there are 4 TVs. Let's say 4 times 100, that is 400 watts, right? That's the first. And the next thing is what? To get the voltage needed for the charge controller, you cascade and then you connect. But always finish cascading your solar panels, you read with the multimeter, you go to your battery, you read. Once you finish connecting your battery, you read. Connect your battery to your what? Your charge controller. Connect your panel to your charge controller. Your charge controller will come up. You see it coming up. You connect the batteries to the inverter. You connect the house. When you connect the battery to the inverter, you start the inverter, you see the output. You can read it if you have a multimeter. And then you connect your inverter to the house. Then you start it. There will be light, right? Are there any questions or anything?
Hello, good afternoon, everyone.
Yeah.
Please, I have a question regarding where we calculated for solar irradiation. So, was it the energy need that we calculated? That place you use the energy need all over solar irradiation times efficiency of the system times solar panel efficiency.
Okay, but at that point we already had kilowatt peak, the total panel size needed.
My question goes to after installation. Is it advisable that the client will start making use of the inverter immediately after installing? Like you just finish installation?
Okay, thank you very much for that question. So most times it depends. So, but generally, rule of thumb for your own safety, after installation, you tell the client to leave it so that the batteries will be what? Will be charged. So you can see there are 3 zones here, right? Zone 1, Zone 2, and what? And Zone 3. Right? So you can see that if you look at this picture, you see here is around 6.5. It's 6,500 watts, but if you divide by 1,000, you get kilo, right? So here is around 6.5. So somebody in Maiduguri, Damatu, Dutse, and all these places, they are going to use 6.5 in their own value of irradiation. Then if you come down and see how the color is changing, here is around 5.5. So you see all this area that is yellowish in color is around what? 5.5. We have not reached Enugu yet though. You understand? So that should be around what? 5.5 kilowatt per day. And then when you now come to this size that are more blue, you are getting down to 4.5. And then when you get to Port Harcourt, all this area, Lagos, you are getting to what? 4. You understand? So this chart will be able to help you specifically get a particular irradiation depending on the location that you are in. All right, so my next question is going to be more practically oriented. Say somebody has one AC that is 1,000 watts. Who can tell me the amount of solar panels you need to power that one AC that is 1,000 watts for 1 hour?
Okay, we are using the air condition 1,000 watts for 1 hour. So our power will now be 1,000 watts per hour. Since we are multiplying the power of the air condition times the time that it is operated, then after we've gotten that answer, we divide by the solar radiation, the what's this called? Solar radiation and efficiency of the panel and all of that, which is 0.9 times 0.5 times 5.5, and we get an answer as 404.04. This should be in watts per peak. So after we've gotten that answer, we divide by the solar panel size that is in the market, as you said. So we're using the one of 250. When we divide that with 404, we get 1.6. Then since the panel has to be 2 by 2, we approximate to the nearest even number, which is 2, and that's 2 pieces.
So how many watts panel?
250.
250 watts panel. So she's correct. All right, so let's put our hands together for the both of them. She has won your money. All right. Thank you very much for the time. Thank you very much for the engagement. It was really fun to meet you guys. Thank you very much.
I congratulate you in advance, hoping that you will weaponize what you've learned today. You will go and sit down, you will pay some price, you will do research, you will find out the latest technology, now that you have the baseline knowledge from a one-day session. But before I sit down, I just wanted to share this. This is called the cone of learning, how learning works. How learning works. Learning works with 2 things, passive and active. Those are the major things I want you to concentrate on, passive and active. If you try to go away 2 weeks from now and teach somebody everything you've learned here, it means you'll remember it for a very long time. It will become part of you. So please, knowledge is not gathered for storage. It is gathered for transfer. The transfer of knowledge increases your retention. If your own works out and you run a big company 6-7 years from now, you can help us reduce the unemployment burden in the land. Thank you for your time. Have a wonderful evening. God bless you.